a small population of excitatory neurons. Fire rapidly and repeatedly to reach threshold. Okay? So let me illustrate that. So at any given instance, many neurons are receiving information from a number of different sources. All right, let's think of a structure in the brain called a thalamus. The thalamus is going to filter incoming information, sensory information from a number of different sources, and it's going to decide on which information it's going to allow to continue and go to the cerebral cortex, where we will have an awareness of that information. You don't have an awareness of anything. You don't see anything, you don't hear anything, you don't hear your own thoughts, unless you're stimulating cells in the cerebral cortex, the outer 6 layers of cells on the big part of the brain. Okay? And so deep inside is this organ called, this part of the brain called a thalamus. And right now, your thalamus is receiving information about the temperature of this room, whether it's too hot, too cold, whatever the case is. But at the same time, the thalamus allows you to hear the fan going, maybe somebody talking in the hall. All of this stuff was coming in all the time. But what the thalamus does is it draws your attention to whatever is pointed out. And the same information was coming in, but the thalamus said, okay, you're important at the moment, so I'll let you go up to the brain, think about, and now you're aware of somebody out in the hall talking, all right, or the fan here, or your clothes touching your skin. All of that was going on, but not until you drew the attention to it did the thalamus allow that information to continue. Okay, and so that's an example of spatial summation. How many different neurons, some excitatory, some inhibitory, are going to add their effects together at any given instant to determine whether or not an action potential will be reached. All right, if you have X number of inhibitory neurons firing at the same time of X number of positive neurons, then you have to add their combined effects to see if the change is positive enough to reach minus 55. If that change in response reaches minus 55, then you will get an action potential. If not, you get a greater potential. Okay? All right, understanding how temporal summation works. All right, in temporal summation, we'll take a break in a little while, but in temporal summation, I hate this. I always got to think about it. It's a good man. We're supposed to have a break at 2:15, right? All right, let's take a break now. Wait. It's okay. You all are so polite. Just let me know when we're going over. Okay.
downstairs gets nice.
Thank you.
The downstairs gets nice.